Now let's try to find the probability of two or more independent events. So over here I got this definition for probability of independent events, and what the definition says is events A and B are independent events if and only if the probability of A and B is equal to, that's right here, the probability of A and B is equal to the probability of A times the probability of B. Okay, so with that being said, the converse is also true. If probability of A and B, or if they are independent, then we can just use this formula right here. Otherwise, A and B are dependent. That's what they're saying over here. Kind of extra information for you. So let's just use this. So this is what they're saying. If two things are independent, then you can just multiply the probability of them for the two things happening to get the probability of both of them happening. So let's just think of it this way. Let's say I have a number cube. I'll draw a number cube right here. And then I have a coin, and this is my face on my coin. My little guy on the coin. And I want to flip it. And I want to get either a head on, let's try to get a head on this, and let's get a 5 on my number cube. Well, what's the probability of getting a 5 on the number cube? Well, there's 6 sides to a number cube, right? So the probability of getting a 5 is equal to 1 over 6. And what's the probability of getting a head? Probably getting a head? Well, that's just equal to 1/2, because there's 2 sides and there's only one side with the head. So what's the probability of rolling a die, getting a 5, and flipping a coin and getting a head? Well, to figure that out, it's as easy, since these are independent events, of multiplying the probability of 5 times the probability of a head. So the probability of 5 times the probability of a head is equal to 1/6 times 1/2. And remember, when we multiply, we just multiply the numerator and the denominator, so we get 1 over 12. So the probability of getting a 5 on the cube and a head on the coin at the same time is 1 out of 12. So that's my example right here. Let's take that and apply it to this problem down here. So we got a bag, and it contains 9 red marbles, right? And it contains 3 green marbles. So we got a bag with that. Let's just draw this bag down here. I like drawing pictures. They help me out. There's my bag. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are my 9 red marbles and my 3 green marbles. 1, 2, 3. Okay. And bag B. So this was bag A. Bag B contains 9 black marbles. Oh, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. And it contains 6 orange marbles. So I got to get the color orange here. Let's get that. Okay. 1, 2, 3, 4, 5, 6. Okay. And the question asks us to find the probability of selecting 1 green marble from bag A and 1 black marble from bag B. And I'll put B down here. Okay. Now, the first thing you got to ask yourself are these independent events? Is picking a marble from bag A going to affect the probability of choosing a different marble from bag B? Well, no, it wouldn't. They're independent events. And so let's try to figure this out. Find the probability of selecting 1 green marble from bag A. Well, what's the probability of getting a green marble from bag A? Well, I got to figure out how many marbles are in there. So there's 9 red and 3 green. So altogether there's 12 marbles. And how many of those marbles are green? Well, there's 3. So the probability of getting a green marble is 3 over 12. And then it says also find the probability of selecting 1 green marble from bag A and 1 black marble from bag B. So let's try to figure that out. So we have 9 black marbles and 6 orange marbles. So altogether you have 15 marbles. And how many of them are black? Well, there are 9. So to figure out the probability of these two events happening at the same time, what do you have to do? You just have to multiply these two things. Multiply these two things and we get 3 times 9. Well, that gives us 27. And we get 12 times 5, or 15. Oh, what is that? 12 times 15. We got 150 plus 2 more, which is 180. 180 right there. Now, can we simplify this down? I'm guessing we probably could. How did that simplify down? We could take a 3 out of this and make that a 9. If you take a 3 out of 180, that makes this a 60, right? Can we take another 3 out of it? Oh, yeah, we could. If we take another 3 out of it, we're at 3, and take a 3 out of this, we're at 20. I think that's the best we get. So the probability of selecting 1 green marble and 1 black marble from bag B would be 3 out of 20.